Hello, dear students, and welcome back to part 4 of GCE preparations online. In this particular topic, we are focused on algebraic processes. And in this edition, we have the following lessons: revision of the number line, factorization and expansion of binomial expansion, numerical value of expansion, simple linear equations, and some past GCE questions, all prepared for you. You actually employ indulgence to watch this video to the end, and equally to leave your likes and your comments so that we know exactly on how much more to aid you in your preparations process. Don't forget to subscribe and to leave a comment. When you subscribe, you click on the notifications bell so that immediately we upload a new video, you'll be immediately and instantaneously notified. Let's begin. So we start by looking at the basic definitions of terms in algebra. Definitions of the basic terms in algebra, which we encounter. So algebra is a branch of math that uses mathematical statements to describe the relationships between things that vary over time. It uses letters and symbols to represent quantities, and in the formulas and equations. Let us look at some terms in algebra. The first term is a variable. A variable is a letter that represents a number. A variable is a letter that represents a number. For example, X is a variable, A, B, C, T, S. In fact, any symbol or letter can be used to represent a variable. And the coefficient is that number in front of a variable. The coefficient answers the question, how many? For example, if you say X, it answers the question, how many X? Is it 1X, 2X, minus 10X, 20X, or whatever? That number that answers the question, how many, is called the coefficient. For example, here in 2X, the coefficient of X is 2. The next one is a term. We define a term as the product of a variable and its coefficient. The product of a variable and its coefficient. For example, 2X is a term. Example, 3X is a term. And all of these are also terms. Like 47 will be called a constant term, but it's not actually a good example here. Minus 6a is a term, 12b is a term, and so on. Note equally that if we consider just X on its own, X will be a term whose coefficient is 1. Then constants are numbers that are added or subtracted from terms. So constants, the difference between a constant and a coefficient is that a coefficient is a constant that is in front of a variable, but a constant is a number that stands on its own. Okay, we are going to see that in an expression. So for example, here in 5x plus 7, 7 is a constant. Okay, now what is an expression? An expression is the sum of terms and constants. For example, you have 3x minus 7, 21z plus 3, 8 plus 2z's. Okay, so an expression is the sum of terms and constants. Or an expression is equally a group of terms not linked by an equality sign. As you can see here, these are expressions. There is no equality sign. When you bring in an equation now, when you bring in an equality sign now, you now have what we call an equation. So we have algebraic expressions as well as algebraic equations. So with the equality sign, we now talk of an equation. Please, guys, make sure you watch this video to the end because the package is solid just for you. Let's look at this. Is this an expression or an equation? It's an expression because there is no equality sign. So this is an expression, as you can see. And in this expression, like in past exam questions, they usually ask, in this expression, X and Y are variables. Okay. Now 5 and 7, 5 and minus 7, sorry, 5 and negative 7 are coefficients. 5 is the coefficient of X and negative 7 is the coefficient of Y, while 3 is a constant. Then the terms in this expression are, you have 5x and minus 7y. Plus 3 is also called a constant term. Yeah, Plus 3 is also called a constant term. So it's a constant, or it's also called a constant term. So this all together forms what we call an algebraic expression. So all of this is an algebraic expression because there's no equal to sign, so it's an expression. Okay. What about this one now? This is an equation because there's an equal to sign. So we know that in the world of algebra, 1a is equal to 1a rather is equal to a. So in the world of algebra, 1a is equal to a, and equally still negative 1a is equal to negative 1a is also equal to just negative a. So if you want to write a, want to write x, you must not put the 1 in front. If you want to write negative a, you may decide to write just negative a without putting a negative 1. However, these two, they mean the same. So whenever you see this, just understand. So now we look at what are like and unlike terms. You always say about like and unlike terms. Let's look at what are like and unlike terms. So what are like terms? Like terms are terms from the same family. These are terms from the same family. And what do we mean by family? We are going to explore that here. So for example, oranges and oranges are terms from the same family. Bananas and bananas are terms from the same family. And if we have to talk about oranges and bananas, these are now terms from different families. So let us look at this. We can add oranges to oranges. They can be added and the result will be oranges. So mathematically, if we have to represent this using a variable, let a be equal to the variable orange, then we'll have 3 oranges plus 3 oranges. And this will give us how many oranges? 6 oranges. So we can see that these are terms from the same family because we can add these 2 terms and the result is a single term. So when we add the 2 terms, the result is a single term. Now let us look at what happens when we add oranges to apples, for instance. So if you have oranges now plus apples, what is the result? The result is 5, right? Okay, the result is 5, but now is the result 5 oranges or 5 apples? Because we cannot have a unique or a single term for these two, bringing these two together, it means they are not like terms. So it does not work because they are not like terms. Apples and bananas are not like terms. So we say that they are unlike terms. And unlike terms are terms we call terms from different family, and like terms are terms from the same family. So thus like terms are terms that can be added or subtracted, while unlike terms are terms that cannot be added or subtracted into a single term. So the important thing there is that to compile into a single term. So let's simplify the following. We have 2a's plus 5a's. That does not give us 7a's because they are like terms adding like terms. 4x minus 5x is minus 1x or minus x. They are like terms. Y plus 3y is equal to 4y's. They are like terms. Now what happens with 3m minus 2n's? They are not from the same family. It means we cannot have a single result like the other ones, right? So 3m minus 2n remains the same because we cannot bring them together, just like we saw with oranges and apples or bananas and whatever. And let us recall some addition and subtraction of numbers using shortcuts. Students always have a lot of issues with negative this plus that and so on, and they always fall out the results. So let us look at adding 2 numbers. When you can add 2 numbers, you can extend that to adding 3 numbers and so on. We look at some shortcuts. These shortcuts are from my math angel. We thank them, we give credit to them for this lesson, my math angel. My math angel focuses on mathematics of Form 1, Form 2s, and Form 3s. And Math 24 focuses on high school mathematics, all of these concepts too. So to add 2 numbers with the same signs, we maintain the sign and we add the digits. So this is just the shortcut to add 2 numbers with the same signs, okay? We maintain the signs and add the digits. So note, a number is made up of the sign and the digits. I want to emphasize on this. A number is made up of the sign and the digits. Let's look at plus 3 plus 5 equals 8. So the signs here are, you have the plus sign, We equally have for the digits are in yellow. We have the digits 5, 3, and 5. With the digits, you don't know whether the sign in front of the digit is plus or minus. Okay. Now, so the digits together with its sign gives what we call a number. That is what we are emphasizing here. The number is equal to the sign plus the digit. All right, so let us see how we apply this now in our shortcuts. So to add two numbers with the same signs, we maintain the sign and add the digits. So this is it. So these are two numbers. Are the signs the same? Yes. So first thing, you maintain the sign. Then you add the digits. 3 plus 4 is 7. This is the shortcut, okay? Whenever the signs are the same, if you have three numbers, first work with 2, and then you bring in the third one. So let us look at the next one. You have -5, -3. So since now that the answer is plus 8, you are wrong. Okay, you use the number line, you start the answer will be -8. So just use this shortcut, don't stress yourself. So you have -5 and -3. These are two numbers. Are their signs the same? Yes. Rule, maintain the sign, then add the digits. That is the rule. If you do that in a calculator, you start the answers are the same. Okay, no stress. Now, if we have a plus 3x plus 4x, the answer also be 7 plus 7x. So if they just add x behind or y behind, the answer is just the same. Okay, so you just add x2. So -5x minus 3x will be equal to -8x. Now let us simplify this. Plus 8 plus 5. What will be the answer? Same sign. So we have the plus sign. 8 plus 5, 13. Okay, the next one. We have -6 minus 9, same sign, maintain the sign, and add the digits, we have -15. Now, what if for the two numbers, the signs are not the same? What about two numbers that have opposite signs? So to add two numbers with opposite signs, this is what we are going to do. We will subtract the digits, start by subtracting the digits, and then you maintain the sign in front of the bigger digits. Maintain the sign in front of the bigger digits. The number that appears looks as if it's bigger. Okay, so a number is made up of the sign and the digits, as we explained earlier. So you can see that that's what the sign is, that's what the digit is. So let us take an example. You have +5 minus 8. Now, these are two numbers, their signs are opposite. So their signs are opposite. What do? I first of all subtract the digits, and I'll take the sign in front of the family that has more members. +8, it means that there are 8 members in this family, right? Then -5, there are only 5 members here. Which family has more members? This plus. So that's why I'm taking plus. So the answer is plus, and then I now do subtraction. 8 minus 5, 3. Example 2. So we have two numbers. The signs are opposite, right? Yeah, we now have the plus. In the plus family, there are 2 people. In the minus family, there are 9 people. Which family has more members? The minus family, right? So we're going to take the sign in front of the minus family because it has more members, and then we do subtraction of digits. 9 minus 2, 7. This is a trick, okay? Mostly use this when I'm teaching Form 1 and Form 2 so that they always remember these concepts. I'm talking about formula and all of those things. That's just a mathematical story. Equally, here we have two numbers, their signs are opposite. So which family has more members? We have there are more elements inside the -8 family more than the +2. So we're going to take the sign of the minus because it has more members, and then we do a subtraction of 8 minus 2. That gives us 6. If they add x behind all of these things, it does not change anything, or y, just maintain the thing as long as the families can be added, subtracted. What about this one? Okay, you can do this one. Which family has more members? You maintain that sign. They subtract the digits. Oh, you can see how easy this is. So we go back to our work. So here you just recall, to add two numbers with same signs, you maintain the sign and add the digits. Why to add two numbers with opposite signs? What you have to do is subtract the digits and take the sign in front of the bigger family. These shortcuts are very important because they are fast and simple. You can take these other exercises, okay? So to add 2 or more numbers, what you have to do is you first of all do 2, then you bring in the third number after you have your answer. Let's go back to our lessons with multiplication 2 as well. Don't recall the multiplication table. A positive number times a positive number is a positive number. Positive number times negative number is a negative number. Negative number times positive number is negative. And negative times negative is positive. So we can use these shortcuts that same sign times same sign is always positive. When the signs are the same and you're multiplying, the result is always positive. Can you see? So negative times negative is positive, and positive times positive is positive. So to multiply two numbers, we first multiply the signs, then the digits. Okay. Like here, plus 3 times plus 2. Plus times plus is plus. 2 times 3, 6. Minus times minus is plus, because the signs are the same. And then 5 times 2, 10. Minus times plus is minus. And then 2 times 4, 8. Plus times plus is plus. 3 times 4, 12. Plus times minus is minus. 3 times 5, 15. And the same with all of these other ones. And see how the results are. Make sure that as you watch this video, you also try to solve these examples, because if you don't solve the examples, you might just be watching this video in vain. If you gain the knowledge and you cannot solve, then you have actually not learned anything. That's the trick in mathematics and all of these drill and practice subjects. Now with division, the rule is the same. On the table, you just have to change the times or the multiplication to division, and everything remains the same. So positive divided by positive is positive, and negative divided by negative is positive. In fact, the same divided by the same is positive. When the signs are opposite and you divide, we have negative. So like here, plus divided by plus is plus, 6 divided by 2 is 3. Minus divided by minus is still plus, and 5 divided by 1 is 5. Minus divided by plus is minus, and 4 divided by 2 is 2. 10 plus divided, there is no number in front of the 10, there is no sign in front of the 10, rather, it is plus when there is no sign. So plus divided by plus is plus, and 10 divided by 2 is 5. Plus divided by minus is minus, and 3 divided by 3 is 1. And the same with all these other examples. Okay. Now, students may usually make a mistake here. Be careful with this one. Minus divided by plus is minus, and 2 divided by 4. 2 divided by 4 is a half. 2 on 4 is a half. So since we always write 2 here instead of writing a half. Don't make that mistake. Okay, so, and then I want you to also note this, like plus 3 plus 4. Look at it again very well. Plus 3 plus 4. Since we make a mistake, when you have two signs not separated by any number, look at these two signs here, not separated by any number. Can you see? When you have two signs not separated by any number, to simplify this, how you write it, these 2 plus will become just a single plus. All right, so now we have 2 again here, not separated by any number. It means plus times minus. And what is plus times minus? It's minus. So I'll replace this plus times minus by minus. What about minus times minus? Look at these two signs not separated by any number. This minus times minus gives us plus. So this is where your teacher tells you that, minus times minus, you have the two minus signs together not separated by any number. That gives you plus. And minus times plus is equal to minus. Okay, good. So the summary of the lesson: to multiply two numbers the same sign, you have already explained all of this, and here are some examples equal. We go back to our collecting terms. To get these notes, you can get these notes at GCE Math Panel. Just go to www.gcemathpanel.blogspot.com and you get these notes from there. Or if you are enrolled for GCE preparations at GCE Preps platform, GCE Preps platform is www.gcepreps with S, gcepreps.blogspot.com. So if you go there, you can actually enroll. You have all of these notes, you have quizzes, and you have live online classes for full-time preparation for mathematics and other subjects. So collecting terms. We go back to our algebra, where the main parts. So collecting terms is all about bringing like terms together. For example, simplify the following. We have 2x minus 4 minus 5x plus 7. So the first thing you have to do here is you start by identifying terms from the different families present. So what are the different families present? We have the x family. So we have to have terms in x. Can you see this? We have 2x and we have minus 5x. So these are like terms, right? Good. And then other set of like terms, you have the term, the constants from the constants. Minus 4 is a constant and plus 7 is a constant. So the next thing now we have to do is to bring them together. We have to so after we have identified these terms, now we can actually simplify. So we have 2x minus 5x, and this will give us a minus 3x, right? And minus 4 plus 7 is plus 3. So we have simplified. So the next example, we have 3x plus y plus 7y minus x plus 6y. So we equally start by identifying terms from the different families present. So we have the terms in x, we have 3x and we have minus x. We equally for the terms in y, we have plus y, we have plus 7y, we have plus 6y. So here we start with the x, we are going to have 3x minus x, 3x minus is like 3x minus 1x. That gives us 2x, and y plus 7y is 8y plus 6y. That gives us 13y's. Okay, so we have 14y's rather. We have y plus 7y's is 8y's plus 6y is 14y. Now there is a very, very important thing that you should not do. That's why we have this red card here. You should never do. We are going to see it. Okay, now let's look at this. In this family here present, we start by identifying the terms from the different families. We have the x squared family, 3 members. We have the y family. We first of all have plus 5y. We equally have minus 9y. Then we equally have the x family. So how many terms, families of terms are present here? There are 3. So together we have 3 families of terms. The family in x squared, the family in terms of y, and then in terms of x. So x squared and x, hold your ear, this is where we want to emphasize. X squared and x are not like terms. So you cannot add them into a single term. You can never do that. Because many things will come here and say, now 3x squared minus x will give us 2x squared. No. X squared, though you have x as a variable, but the x squared now becomes a different variable, it's a new variable. So you can never add x squared to x. Good. So that's why the referee has given you red card. Now, so to simplify this, we have only one term from the x squared. So we have 3x squared. Now for the y's, we have plus 5y minus 9y. That gives us minus 4y and minus x, which is alone. So when this is simplified, this is what we obtain. You must take note of this. So we follow the same procedure in collecting all other terms. Okay, let us start by looking at factorization. So factorization is the process of inserting brackets. You identify the highest common factor and you factor it out. For example, let us factorize the following. We have 2x plus 4. So the first thing is to find the highest common factor, and the highest common factor for 2x and plus 4 is 2. Okay, the highest common factor is 2. So we factor it out. This is 2. We now say 2x divided by this 2. So we open our brackets. Then 2x divided by this 2 that is outside this bracket. Let us see how we do it. So we have 2x divided by 2, and that will give us a 2 here, 1, and then 2 here, 1. So this should be equal to just x. Since equal to x, to copy this value and put inside this bracket. And then now we have finished this 2x. Now plus 4 divided by 2. So next we have plus 4 divided by 2. What does that give us? Just divide again, plus 4 divided by 2. 4 here, 2 here, 2, 2 here, 1. So that's equal to plus 2, right? So I cannot just write 2 here. So the answer is plus 2. I must put a sign here because x plus something. I cannot write x2. That is not correct. So I've put the plus sign. Normally this one is also plus x, but there is no need to put it. So when you factorize, this is what we have. Please don't forget to subscribe and to click on the notifications button so that immediately we upload a video, we are instantaneously notified, okay? Because most of the times you will not get our videos because you have not clicked on the notifications bell. You have subscribed, yes, but you need to click on the notifications bell, okay? Let's take another example. So we have 6a's minus 3c's to factorize. The first thing is to find the HCF. And what the highest common factor here is 3, right? So we are going to bring out that 3, open our brackets. Then we have 6a divided by 3. So 6a divided by 3, this will give us 3 here, 1, 3 here into 6, 2 times 3 into 3, 1. So that gives us 2a. We copy it into our bracket here. Next, we divide minus 3c by 3. So minus 3c divided by 3, we go to our rough sheet here. Minus 3c divided by 3. So 3 minus 3, that's go minus 1 time once. So we have minus c. Copy this and minus c into the bracket. So we have factorized this one completely. Now, next example, we have 3a squared minus ab. 3a squared minus ab. The first thing is to find the HCF. So we start a is common because this 3a squared is like 3aa. Okay, so this will be equal to a is common. Then we open our brackets. So now 3a squared divided by a. Note that 3a squared is like 3 times a times a. So I've written 3aa divided by a. So one of these a will cancel out one of these a's and we'll be left with 3a. We copy it into our brackets here. And then the next thing we divide minus AB by A, minus AB by A here, please. So this will give us minus AB divided by A. A here will cancel one of those A's, we'll be left with minus B. We copy it into a bracket. So the factorization is complete. Another example, we have 5x squared plus y plus 3xy squared. So we start by looking at the constants. Between 5 and 3, there is no common factor, right? The common factor is just 1. There's no need to write it. Then between x squared and x, the common factor is x. And between y squared and y, the common factor is y. So our common factor here will be x times y, xy. But when you look at x squared and x, what's the highest common factor? It is x. This is it. Now look at the y. Y and y squared, the highest common factor is y. So we open out our brackets now and divide 5x squared y divided by xy. So 5x squared y is equal to 5xy divided by xy. So we'll be left with 5x, right? And then, so we copy it into these brackets here. Then we have plus 3xy squared divided by xy. That's what will give us. So plus 3xy squared is plus 3xyy divided by xy. We cancel that, we'll have plus 3y as a result. Okay, we copy it into this bracket here. So so that's factorization 1. Let us add something small again now. Looking at this type, you can see that the highest common factor is already there in brackets. Look at these two brackets. So the highest common factor here is already a minus 1, because this is a term here, and it's another term. The highest common factor is a minus 1. You can see that. So we just copy out this bracket. And this one is very easy. What we have not used, what is left outside the brackets now is this a minus b. We copy it into the other bracket. This is a minus b. Factorization complete. What about this one? We have x plus 1 and x plus 1. You can start it. We already have some good thing in brackets already. The highest common factor is x plus 1. We just copy it. And what is outside the bracket is x plus 4. Okay, so we have factorized this directly. Most of the past questions, you see this type of simple examples. Okay. Now, factorization is the process of removing brackets. Let us look at this other example. Now we have 4 terms. Whenever you have 4 terms like this, what we start with is you start by grouping them. Okay, let's call this first 2 group 1 and this other 2 group 2. So we group them. Okay, so now for the first group, the highest common factor of these first 2, you have x squared plus 2x. The highest common factor is x. So x squared divided by this x will give us x. Now plus 2x divided by x will give us plus 2. And this other group, there is no common factor, right? So the highest common factor is plus 1. Open our bracket. Now plus x divided by plus 1 is just x, and plus 2 divided by plus 1 is plus 2. At this step now, there is a highest common factor again inside these brackets. The 2 brackets are the same. So we just copy out the brackets, and what is outside these brackets, x plus 1, we put in another bracket. And the factorization here is complete. Okay. All right. So let's take this other example. We have x squared plus x plus 4x plus 4. So we group into 2s. So this is group 1. Let's call this other group 2. So with the first group, the highest common factor is x. So x squared divided by this x will give us x, and plus x divided by this x outside will give us plus 1, right? The next one, of the next group, we have plus 4. We have plus 4x plus 4. So with this other group here now, highest common factor is plus 4. Plus 4. There must always be a sign here before this number, okay? Plus 4, we open out our brackets. Now, plus 4x divided by this plus 4 will give us x. And plus 4 divided by this plus 4 here will give us plus 1. Now, we have the same thing in the 2 brackets. So we just copy out one of these brackets, and we are left with x plus 4 in the other bracket. So the factorization is complete. Whenever they ask you to factorize and leave your answer in the form of a product of linear factors, this is what they mean. It means that the highest power of x is 1. So we are indirectly doing some sort of quadratic factorization here, which we equally see in part 7 of these preparations. What about this other one? We have x squared minus 2x minus x plus 2. So with this case, we group again into 2. So with the first group, the highest common factor is x. We open our brackets. Now x squared divided by this x outside gives us x. Minus 2x divided by this x outside gives us minus 2. So for the second group, looking at minus x and plus 2. The highest common factor, and this highest common factor should always take the sign in front of this first number here, okay? The sign in front of this first number before the last one. So we have the highest common factor should be -1, okay? So normally I always say that you should bring down the signs so that you should not forget. So now -1, open out our brackets. If you put a +1 here, what will be in the two brackets will not be the same. So you have negative x divided by -1, that gives us x, and +2 divided by -1 gives us -2. Okay. I don't bother in this video. Plus and negative, plus and positive are interchangeably used. All right. So since the two brackets have the same values, you just copy out one of the brackets, and in the other brackets you have x minus 1. We have x minus 1. Now here we have x squared minus 5x minus x plus 5. So we group this as well, group 1 and group 2. With the first group, the highest common factor is x still. X squared divided by this x will give us x in brackets. Minus 5x divided by x will give us minus 5. The second group, remember that the sign should be the sign in front of this first number here. So our highest common factor there, that is -1. Now minus x divided by -1 is plus x, and plus 5 divided by -1 is -5. The two brackets are now the same. If you use the different sign here, you start the two brackets will not be the same at the end. So it means I can still factorize again. Here the highest common factor is x minus 5. I bring it out, and what is left is x minus 1, which I put in another bracket. This is how simple factorization is. To get these notes, go to www.gcemathspanel.blogspot.com, or you go to gcepreps.blogspot.com, where you can get these notes and notes for all other subjects. That's said with factorization. We now look at expansion, which is the process of removing brackets. In factorization, we're inserting brackets. Now in expansion, we are removing brackets. For example, expand the following. So we are doing the opposite of what we were doing before. Okay, brackets are already there, I want to remove them. So here we expand by multiplying each term in the bracket by the terms outside the bracket. So we have, for example, 2 into x plus 3 will be 2 times x. This is 2 times this x, so 2 times x, this is it. Now plus, this is plus, right? Plus 3 or plus 2 now times 3. Good. So this is it, and then we now simplify. So this number times this number plus this number times other number inside. So this gives us 2x plus 6. I think we factorized this before, and we had 2 into x plus 3. Now we have expanded. Right, we have 5 into y minus 7. So this one to expand, we have 5 times y, which is 5 times minus 7. Or you can take minus 5 times 7. That gives us 5y is minus 35. Okay. Now 3x times y plus 2. So we have 3x times y is 3xy. Then plus 3x times 2, we have 6x. So we have 3xy plus 6x. The next one, we have minus 2x into x minus 4. So we have minus 2 times x, and then minus, so minus this minus 2x times 4. We can just say minus 4 times minus 2x. Okay, so this gives us minus 2x squared plus 8x. Minus 2x squared plus 8x. Now, what if we have the two brackets to expand? With this, we multiply each term in the first bracket by all the terms in second brackets. So let us expand the following. We have x into x minus 1 into x minus 4. If you look at the last examples of factorization, we arrived at answers like this. So we are doing the reverse of those processes. Okay. So what am I going to do now to expand? The rule is I will say this first term here times all of these second brackets And then this second term times all of the second brackets. Let us do it. So we have this x, the first term is x times all of the second brackets. So times x minus 4. And then now the next term, the first bracket is minus 1. This minus 1 times all of the second brackets. Remember that we had something like this before, right? Now we continue with our expansion. We simplify. So x now times x squared. And then x times minus 4 is minus 4x. Minus 1 times x is minus 1x or minus x. And minus 1 times minus 4 is plus 4. But we see that this minus 4x and minus x are terms from the same family. So we have x squared minus 5x plus 4. X squared minus 5x plus 4. Another example is 2 plus x into 3x minus 1. With this, we have 2 times the second bracket, that is 3x minus 1. Then plus, next term is plus x into 3x minus 1. So this will be equal to 2 times 3x is 6x. 2 times minus 2 times minus 1 is minus 2. Now plus x times 3x is 3x squared. Plus x times minus 1 is plus minus, which is minus x. So here we start by writing the term with the highest order. We have plus 3x squared. 6x minus x is 5x. And then we have minus 2. It's always good to write it in this order from x squared to x to the constant term. It's always good to write in this order. But if you write in any order, it's okay. You don't have to bother about that. So we have really touched so much on algebra. What we can just look at now are numerical values. For example, they may always give you some examples and say if you find the numerical value of some expressions. I'll just use some past examples to do this particular aspect. For example, the value of 3y plus 3 on 5x when x is 2 and y is 3 is. So finding numerical values just to substitute the given values into the expression, okay? So we just have, this is 7y plus 3 on 5x. So I'm going to replace y by what has been given when y is 1. So I'll replace this y by 1. So when y is 1 and when x is what? When x is 2. And then we simplify. That is all about numerical value. So 7 times 1 is 7 plus 3, 10. So we have 10 on 5 times 2, 10 on 10, which is equal to 1. So this is all about numerical values. Just substitute the given values of x and y into the expression to find the numerical value. The next example, we have given that y equals -2 and x equals 1. Then the value of y squared plus x plus 1 is the same procedure. So we just have, instead of writing y squared, I'm going to write -2 squared. So plus x is 1, right? Plus 1 plus 1. So this will give us 4 plus 1 plus 1, which is 6. So the numerical value of this expression is 6 when x is 1 and y is -2. Then equally here, given that p is equal to 3 and q equals 2, find the value of p squared minus 2q. So here we just do substitution just like before. So you have 3 squared because p is 3. So we have 3 squared minus 2q minus 2 into 2 because q is 2. So 3 squared is 9. 9 minus 4 gives us 5. This is all about numerical values. We will end this by looking at simple linear equations. So we end this particular topic by looking at simple linear equations. And what are simple linear equations? Simple linear equations are equations in which the highest power of the variable is always equal to 1. That means the highest power of x is 1 or the highest power of y is always 1. And it is also known as a 1-degree equation. The standard form of a linear equation is ax plus b equals 0. This is the standard form, okay? You just have one unknown. So this is the general form because even at the end when you solve, you get to this. So here x is the variable as we already know, and a is the coefficient of x while b is the constant, okay? Let's take an example, the simple case of just addition and subtraction to have the answer. So you have x plus 5 equals 7. Of course, the only number that you can add to 5 to have 7 is 2, right? So we already know the answer is 2. So what we are going to do is let us use the simple example in class. So we are going to, what is the same from having this x is because we have plus 5. So I want to, normally we have to subtract 5 from both sides, but let us do the carrying stuff, okay? So we now, since this plus 5 is disturbing us, we carry it to the right-hand side. Can you see? Carry it to the right-hand side. And that's what we now have. And whenever we carry it to the right-hand side, it was plus, right? Plus 5. The sign changes from plus to minus. Can you see? To minus. Whenever a term crosses the equality sign, the sign should change. Now, what is 7 minus 5? The result is 2. The result is 2. Okay, so x is equal to 2. Example 2, we have y minus 2 equals 11. What is disturbing us from having this y here is this minus 2. What do? Carry it to the right-hand side. You're actually adding 2 to both sides. Don't forget. So when you carry this minus 2 to the right-hand side, the sign changes from minus 2 to plus 2. So y will be equal to 2 plus 11, which is 13. And don't forget, whenever a term crosses the equality sign, the sign should change. We now have 3x plus 5 equals 2. The first thing that's disturbing us from having this x here is this plus 5. The first thing is to remove this plus 5, this constant. So you carry it to the right-hand side, it moves from plus 5 to minus 5. So you will now be left with 3x is equal to 2 minus 5 is minus 3, right? So in the next step, we have 3x to be equal to minus 3. We now divide both sides by the coefficient of x here. Divide both sides by 3. So 3 here, 1, 3 here, 1. Then on the right-hand side, 3 here, 1, 3 here, 1. So we have x is equal to minus 1. X is equal to minus 1. Now we have minus 2x minus 1 equals 2. The first thing that's disturbing from having x here is this constant that's been added, okay? So we carry it to the right-hand side from minus 1 to plus 1. What's the next step? We divide both sides by minus 2. So the left-hand side divided by minus 2. Minus 2 here, 1. Minus 2 here, 1. And that gives us x equal to minus 3 on 2. You know that 3 on minus 2 is also the same as minus 3 on 2. You can leave your answer as 3 on minus 2, but normally it's minus 3 on 2 or minus 1.5, whatever you want to write. Now, case 2, we have, in this case, we have x appearing 2 times. You have x on the left-hand side, we also have x on the right-hand side. We have x on the left-hand side 2 times on the. So in this case, the first thing you have to do is to bring like terms together, and you have to bring all the terms in x on the left-hand side. That's the general rule. If you take all the terms in x on the right-hand side, there is still no problem. So let's bring everything on the left-hand side. We bring like terms together, and all unknowns, the unknowns are the x or y or whatever to the left-hand side. As I've said, you can still take them to the right-hand side, but generally they always take to the left-hand side. So first of all, I'll carry this minus 2 to the right-hand side, and you become plus 2. Let's see what happens. Plus 2, right? But at this position, I also need to take this 5x the left-hand side because I've not removed it. So we take this 5x the left-hand side. Now, this is the equation that we have now. So we have all the unknowns on the left-hand side, and we have the constants on the right-hand side. Okay, so I take it again. So we have, I have to take this minus 2 to the right-hand side, and I also have to carry this plus 5x to the left-hand side. When this minus 2 goes to the right-hand side, the side will change to plus 2, while bringing 5x to the left-hand side, the sign will change to minus 5x. So let us carry plus minus 2 to the right-hand side, it becomes plus 2, that's the 2. And then we now have to bring this 5x to the left-hand side, it becomes minus 5x. We can now simplify. Everything on the left-hand side now is like, or the unknowns from the same family. So next, 3x minus 5x is minus 2x. On the right-hand side, 2 minus 8 is minus 6. We now divide both sides by minus 2, the coefficient of x. Divide the left-hand side, you have minus 2 here, 1, minus 2 here, 1. The right-hand side, minus 2 into minus 6 is 3 times. Minus 2 into minus 2 is 1. So our x here is equal to 3. So our x here is equal to 3. Now here we have 14x plus 7 equals 9x minus 3. So what do? We have to carry our plus 7 to the right-hand side. And we have to bring our 9x to the left-hand side, it becomes negative 9x. Now 14x minus 9x is equal to 5x. And minus 7 minus 3 is minus 10. Now divide both sides by 5. 5 here, 1, 5 here, 1. And on the right-hand side, we have minus 10 divided by 5. So 5 here, 1, 5 there, minus 2. And our x is equal to minus 2. Our x is equal to minus 2. The next case now here, case 3, we have the case of brackets. So with brackets, first of all, expand. We expand when we have brackets. So we have 2 into x minus 1. So we have expanding, we have 2x minus 2 is equal to 3 times 2x, 6x minus 12. We now bring like terms together. So bring this 6x to the left-hand side and take minus 2 to the right-hand side, okay? So we now have 2x. When you bring 6x to the left-hand side, it becomes minus 6x. When you carry minus 2 to the right-hand side, it becomes plus 2. So plus 2 minus 12. So 2x minus 6x will give us minus 4x. This should be equal to 2 minus 12, which is minus 10. We divide both sides by minus 4, and our answer will be 5 on 2. We have 5 on 2 as our answer, 5 on 2. Now here we have brackets and we have fractions as well. Whenever you have fraction, the first thing to do is to cross multiply. Whenever you have fractions, the first thing to do is to cross multiply. So when we cross multiply all of this, we see the results which we are going to have. So when we have this, the first thing to do here is to cross multiply, okay? Whenever you have fractions. So when you cross multiply, we're going to have 5 times 2 into x minus 1. So this is 5 times this numerator here. And then on the right-hand side, that should be equal to 3 times 4 into 2x minus 3. 3 times 4 into 2x minus 3. So 5 times 2 is 10. So you have 10 into x minus 1 is equal to 12 into 2x minus 3. 10 times x is 10x. 10 times minus 1 is minus 10. So this is equal to 12 times 2x, which is 24x. 12 times minus 3 is minus 36. Bring like terms together. So we have 10x. Bring this 24x to the left-hand side. So we have 10x minus 24x. And this should be equal to, you carry this plus 10, minus 10 to the right-hand side becomes plus 10. So plus from minus 10 to plus 10 to the right-hand side, minus 36. Here, 10x minus 24x is minus 14x. And this should be equal to 10 minus 36, which is negative 26. So to have x, divide both sides by negative 14. And x will be equal to minus 26 on minus 14, which is 13 on 7. This is a very good example, 13 on 7. Now, this next one also, what you have to do here is just to cross multiply, okay? And when you cross multiply, you have to input brackets, because whenever you're multiplying an expression by a number, you have to put brackets. So I'll say 3 times bracket open x minus 3, and that should be equal to 2 into 2x minus 3. So this 3 here times, I'm going to put this one in brackets. Yes, x minus 3 is equal to these 2 now times all of this one, this numerator on the right-hand side. I'll put this numerator on the right-hand side in brackets. We now expand. 3 times x is 3x. 3 times minus 3 is minus 9, which is equal to 4x minus 6. We bring like terms together. So 4x comes to the right-hand side, becomes minus 4x. 3x minus 4x is minus x. And we move minus 9 to the right-hand side, becomes plus 9. Plus 9 minus 6. 9 minus 6 is 3. So we have negative x equals 3. Some students will end here. You are not yet at the answer. We are solving for plus x. We want to look for the value of x, not minus x. So here, this one is the same as minus 1x equals 3. We are looking for plus 1x. So here we have to divide both sides by negative 1. And what will be our result? So x will be equal to negative 3. Right, so x will be equal to negative 3. Okay, there is a negative sign here. Negative 3, please. X should be equal to negative 3. So that's equal to negative 3. Let's take some few past questions. So we just focus on the second one. The second one, which reads, normally with the indices, you can equally have something like this. And let's look at the second one that we have. So the second one, you have 5 minus x on 5 is equal to, or minus 2 or minus x on 10. We should simplify this. So to simplify this, you have to look for the LCM. The LCM of 5 and 10 is 10. 10 divided by 5 is 2. 2 times all of what you have here. So you have to put brackets. Now, minus 10 divided by 10 is 1. Okay, so minus 10 divided by 10 is 1. So minus 1 into 2 minus x. So we simplify. 2 times 5 is 10. Okay, 2 times minus x is minus 2x. Minus 1 times 2 is minus 2. Minus 1 times minus x is plus x. All that on what? On 10. And there are like terms here. So we have 10 minus 2, which is 8. 10 minus 2, which is 8. And we have minus 2x plus x, which is minus x or minus 1x on 10. So we have simplified. We have simplified this. And this the other one, to solve this equation, 5 over 7x minus 1 equals 4 on 9. So as we have fractions, we just have to cross multiply. So when we cross multiply, we'll have 4 into 7x minus 1 should be equal to 5 times 9. Open out the brackets, we have 28x minus 4 is equal to 45. And we have 28x on the left-hand side equals 49 on the right-hand side when we carry minus 4 to the right-hand side. So x will be equal to 49 on 28, okay? And when we simplify, we'll have 7 on 4. 7 on 4. Now simplify also this the equation or this expression results in. So when you look at these variables, that there is a common factor. You first of all have to factor out before you can do this simplification. The first one, the numerator is the difference of 2 squares. Difference of 2 squares, and to factorize the difference of 2 squares, you take the square root of the first one. Square root of t squared is t. So you put t in the first bracket, t in the second bracket. Can you see? And what's the square root of 9? Is 3. You put 3 at this position and 3 at that position. Look at what I've done. Square root of t squared is t, and square root of 9 is 3. Now, one of these brackets put plus, the other one you put minus. That's how we factorize the difference of 2 squares. More of this is explained in chapter 7 of or part 7 of these preparations. Now, if the denominator is direct, the highest common factor of the denominator is 2. So the highest common factor of the denominator is 2. We factor out the 2. 2t divided by 2 is t, and 6 divided by 2 is plus 3. So we now see that t plus 3 can cancel out with t plus 3, right? So these two can cancel out and we'll be left with t minus 3 on 2. So this is the final answer, t minus 3 on 2, which is B in this example. And simplifying this one, they just want us to expand and simplify. So we just have 3x minus that. So 3 times x is 3x. 3 times minus 2y is minus 6y. Minus 4 times x is minus 4x, and minus 4 times minus 5y is plus 20y. So bring like terms together. 3x minus 4x is minus x, and minus 6y plus 20y is plus 14y. Okay, so another way you can write this one as 14y minus x. Can also be written as 14y minus x. So you can carry this one with the sign in front. Okay, in this expression, the common factor is, so first of all, look at 3 and 15. 3 and 15. The highest common factor of 3 and 15 is 3, right? So we have 3. And then for x squared and x, the highest common factor is x. Okay, so the answer is 3x. That's the highest common factor. We have seen that when we were factorizing. And given this expression, the like terms are, what are the like terms here? The like terms are 8x and minus x, okay? As you can see, these are terms from the same family. 8x and minus x. How can they ask this type of simple question? Okay. Now, given this expression y plus 4x minus 8, the coefficient of y is 1, right? Because you just want y. We know that y is the same as 1y. So the quotient of y is 1. Wow. I love this type of easy ones. Simplifying this gives, so they want us to, you just have to look for the LCM. X on 2 minus x on 3. The LCM of 2 and 3 is 6. 6 divided by 2 is 3 times x, 3x. 6 divided by 3 is 2 times x minus 2. So 3x minus 2x is x. So the result is x on 6. X on 6. We have x on 6. So thank you guys so much, and don't forget to subscribe and click on the notifications. In the next part, part 5, we'll be looking at indices, equations on indices, logarithms, equations on logarithms, surds and laws of surds, and some past GCEs and solutions and how to tackle them. Thank you so much, and it has been the GCE Maths panel, Maths 24 Super Channel, and the GCE Preps platform. Bye-bye.